Hello everyone, my name is Thomas Di Martino. I'm a first year PhD student at Sondra Lab in Onera, working on the topics of deep learning for S3 and multitemporal SAR images. Today I will present to you our paper entitled Convolutional Autoencoder for Unsupervised Representation Learning of PolSAR Time Series. It has been submitted to IGARSS 2021 and was co-authored by myself, Régis Guinvarch and Laetitia Thirion-Lefebvre from Sondra Laboratory, as well as Elise Colin-Koeniger from Onera. Our work fits in the context of processing multitemporal SAR images. Various studies have shown the discriminative information contained in temporal saxiners and their application to various tasks such as forest monitoring with the detection of forest disturbance and agricultural monitoring with the classification of crop types using SAR Time Series. However, the extraction of such insights most of the time require the use of labeled data in the algorithm training process for the list. These labels can often either be difficult to obtain if insufficient or noisy, or they can also be a huge restriction regarding the information contained within multitemporal SAR images. Hence, we propose an unsupervised method to retrieve pseudoclasses from multitemporal SAR images. For that, we use this two-block method where we first defined a projection function tasked with reducing the temporal dimension of input SAR time series onto a low-sized latent vector. Then we feed the newly projected list of SAR time series to a clustering algorithm. The resulting clusters are acting as pseudoclasses, where samples with same cluster attribution are deemed to have similar temporal patterns, while samples with dissimilar cluster attributions are deemed as temporally dissimilar. The difficulty of the task is then to come up with a projection function that is powerful enough so that it can extract discriminative information from the input time series. For that, we present Convolutional Autoencoder, computed over the temporal axis. It's a deep learning model that will first project, using its encoder part of the model, input time series onto a low-size vector. In our case, it's a vector of size 2. Then, its decoder model tries to reconstruct the original time series from this low-sized vector. The whole model, trained end-to-end using a mean square error or construction loss, by computing distance between the input time series and the recreated time series, is then able to project the input SAR time series onto a latent space where separation is semantically relevant. To evaluate our method, we will compare it to other commonly used type of time reduction methods, such as the temporal average and the PCA. The mutual performance will be compared on a task of unsupervised retrieval of the farm outline in Forêt-Nazaire, France. We notice here in table 1 a numerical comparison of the performance. We see that the convolutional autoencoder projection method can retrieve the farm's outline with much better performance in terms of F1 score. In figure 12, a visual illustration of what this performance means visually displays a very clear advantage of our convolutional autoencoder over the other two methods. For example, as a matter of fact, we see the details of the farm outline, such as its roundish corners, to be retrieved in the convolutional autoencoder pipeline, while it's completely abandoned for more squarish type of corners in both the temporal averaging method and the PCA method. As a conclusion in this paper, we first present an unsupervised methodology to extract, let's say, varying temporal profiles from our multitemporal SAR images without the need of labels. Additionally, we evaluate multiple candidate projection methods, and within them, we introduced convolutional autoencoders, which happens to show the best performance at modeling SAR time series. Thank you all for listening to my presentation. I'm really looking forward to responding to your eventual questions.